Hello everybody, Mr. Taylor here. So we are coming to the end of Unit 6, Statistics and Samples, but we want to talk about mean absolute deviation. Now I'm sure this is a term that most of us have not dealt with before, but it's going to be pretty simple, I think, to get us through it. Your objective is to find the mean absolute deviation of a data set. You have some key vocabularies, and these vocabularies are measure of center, mean, measure of variability, and mean absolute deviation. As we go back and look at these particular definitions, and we will have a next slide, we'll talk about, well, 2 slides from now, we'll give you actually these definitions. But I want you to know that you know them. You know them already. We talk about measure of center. We're just talking about central tendencies, and these central tendencies you know already are mean, mode, and median. You know this. You know it already. We know that when we talk about mean, we're talking about taking the average of a data set, and measure variability is simply the range, smallest from the largest. In this case, one of the actual one. What we will focus on here is mean absolute deviation. And what I'm going to do next is I'm going to sort of break this down for you so it'll be, pretty much clear to you. Well, what are we talking about when we talk about mean absolute deviation? Well, if we were an ELA class and we were to try to determine what this means, we'd break each one of these down. So this is what I want to do here. The means would be just simply taking the actual average of a data set. So let's just say, for instance, we have 5, 10, 15, 20, 25, and we want to find, well, what is the actual average of this data. So we would add 5 plus 10 and get 15, and 15 plus 15 and get 30. 30 plus 20 will give us 50, and 50 plus 25 will give us 75. And then we would count how many, 1, 2, 3, 4, 5. Since we have 5 data sets, we would divide that by 5, which means it will look something like this. And we will get 1 here, so that's 5 and 2, and then we would get 15. So we would get a mean of 15, or an average of 15. Then what about absolute? When we look at absolute, in this situation, we're talking about absolute value. So if I set up a number line and I have 0, 1, 2, 3, and -1, -2, -3, and I ask you, well, what is the distance, or how far is -3 from 0? Well, you would count, very intelligent kids, 1, 2, and we say it's 3 units. And then I said, well, how far is 3 from 0? Then again, you do 1, 2, 3, and again, you'll say 3 units. What you wouldn't say is this is a -3 and this is a positive 3 units, because you're just counting units. So when we look at absolute value, we don't use the negative numbers at all. That's going to be vital in what we're going to be doing here. And of course, deviation means just how far something is. If you look at deviate, means to probably like a detour. So if you have, maybe you're going from point A to point B here, and then we have something that's closed off to here, and then you have to deviate and go to point C, and from point C to point B, and then we'll just determine how far we did, or how far we went to get from A to B. So deviation just simply means how far. So here is the definition page that I talked about. So you might want to stop it here and copy these definitions. A measure of center is a single number used to describe a data set. A measure of center, one measure of center, is called a mean. which is the sum of the data values divided by the number of the data values in the set. So that means you're going to add up the data values and divide by how many you have. A measure of variability is a single number used to describe the spread of a data set. One such measure of variability is called a mean absolute deviation, which is the mean distance between each data value and its mean set. A lot of fancy words, a lot of definitions that may seem a little confusing. So the best way to do it is just to do it. Okay, so what I want to do, I have to give us two problems that he wants us to actually look at to practice. I want to do the first one for you if it's okay with you. So if I look at problem one, and first thing problem one is asking me to do, it says calculate the means. So we know what means mean. It means to add up 60 plus 58 plus 54 plus 56 plus 63 plus 65 plus 62 plus 59 plus 56 plus 58. And when we add these all up, we get a total of 591 via my TI Inspire. Now, I have a total of 10 data points. So I'm going to divide 591 by 10. So this looks like this, 10 divided into 591, and that's going to give me 59 with a remainder of 1, 59.1. So it tells us to round to the nearest whole number. So since 1 is less than 5, then we will estimate this as 59.0. Okay? Now, the second thing it says is to complete the table. So what they want us to do is take the means and subtract the means from each one of these numbers, and that's all you're going to do. This is what absolute value is going to come into play. So if I just say, if I subtract 60 minus 59, I'm going to get 1. If I subtract 58 minus 59, I'm going to get a -1. But absolute value is what? Positive. So it stays a positive 1. And we do the same thing. So here would be 54 minus 59. That's going to give me a -5, but it becomes a positive because we take an absolute value. And we go on just like we're doing here. We get actually 3. We will get 4. We will get 6. We will get 3. We will get 0. We will get 3. And we will get 1. So what we've done is we found our distance. Each one of these is from 59. So how far is 60 from 59? How far is 58 from 59? How far is 54 from 59? So we did this addition and actually subtraction, and now to find the MAD, we just add these up and divide by the number. So if we add 1 plus 1, that's going to give us 2, and 2 plus 5 will give us 7, 7 plus 3 will give us 10, 10 plus 4 will give us 14, 14 plus 6 will give us 20, 20 plus 3 will give us 23, 23 plus 0 will remain 23, 23 plus 3 will give us 26, and 26 plus 1 will give us 27. So here to find the MAD, we know we have 27, and how many data points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll divide that by 10, and this is the way it looks. 10 divided into 27 will give us 2, and that is a 2.7. So 2.7 can be round to the nearest whole number. Since 7 is greater than 5, it will be approximately 3. Okay, looks good. So this is what they're asking us to do. Really simple. we found the means, then we subtracted the means from the distance, and we came up with the distance from the mean each. We added them up, divided by the number of data points, and that gave us our MAD. And what the MAD do, it determines, just like it said, how far it is or how far apart your data is. So this is a pretty low, the lower it is, the closer your data would be. If we were to look at a scatter plot, it would be clustered around the actual trend line or the actual the point clustered. Okay, let's move on. So here, stop it for me, and you work B. Remember, you're finding the means, round it to the nearest whole number, subtract it from this group of data here, and once you subtract, add that up, add these numbers up, divide by how many points you have, and then that will give you your MAD. So go ahead and stop it, come back when you're done, and we'll check. Okay, next thing is just now that you've come up with both, look at both A and B and compare the MADs. Look at the MADs only, and how do the MADs describe the distribution of height in each group. Remember, the closer it is, the smaller the number, the closer it is to the mean. And so that's what you want to put here. All right, here we go. So this is the author's answer. Notice approximately 59. Then we're going to take 59 and subtract from each number. There are your absolute value numbers. Add these up, divide by the number of data points, and you get approximately 3. That's the same thing we got. So looking good. Now let's see how well you did. Well, if you add 46, 47, 56, 48, 46, 52, 57, 52, 45, you'll get 449. You have 9 data points. Divide by 9, you'll get 49.9. 0.9 is greater than 0.5. Let's round up, and we get approximately 50. So now we go down and subtract 50 from each one of the points. That's 4, 3, 6, 2, 4, 2, 7, 2, 5. Now, in order to find this is the distance. It's not the MAD, it's the distance. So in order to find it, the MAD, we need to add each of the distance, divide by the number, and we'll get approximately 35. And that's 3.9. It's then round to the nearest whole number, so we get approximately 4. So if we go back and compare A to B, we see B is 4, and what do we get for A? We got 3. So now let's answer the reflect question. The MAD in part B is greater. The height in part B are spread out more than the means and then the height in part A. So that means that part A is closer, the variability is closer to the center than part B. All right, so this is how we want to do it. And we look at this math talk. It says, what is the difference between a measure of center and a measure of variability? And it tells us that a measure of center is a number that indicates where the middle or center of the data set is, while a measure of variability is a number that indicates how much the data set spread out from the center. All right, good job, guys. This is Mr. Taylor. Listen, if you haven't subscribed and you feel that these are useful, please do so. And as always, leave a comment. I'm more than welcome to look at any suggestions that you may have to make this a better fit. I'll see you soon.